there, kids. Welcome to another math video. This is for Eureka Math, and it's grade 5, module 2, lesson 12, homework. So hopefully at this point you have already done your homework and you are just checking. If you haven't done that, please go watch the problem set video and learn how to do this lesson first, because I've got, always helpful hints about what to do. The homework is just, you should know how to do it, so you're doing it, and now you're checking it. So first thing you have to do on the homework is to estimate. Then you have to solve, and we are using the standard algorithm. You may draw an area model if it helps you, and look how much space they gave you. So if you want to do that, go ahead. I usually don't because I just find it annoying at this point. So let's jump right in and start working on these. If you have a number like 24, and you're multiplying it by 2 and 31 hundredths. Notice the little wiggly sign because we're supposed to estimate first. So estimates may vary, and kids may say, well, I want to do 25 times 2 and get 50. And others would say, why should I change 24 when I can do 24 times 2 and get 48? And so the estimates may vary, and these are both fine. I believe the answer key actually says this one, but I would personally use this one. So anyway, we jump right over to the standard algorithm and start working with our ones place. So 4 times 1, 4 ones times 1, we have 4. 4 times 3, 12, carry the 1. 4 times 2 is 8 plus 1 is 9. And so again, you want to not hassle with the decimal. When you're using the standard algorithm, leave it out until you're finished. So second step is to use the 2 in the tens place, which means get to the tens place. 2 times 1, 2. 2 times 3, 6. 2 times 2, 4. Nothing carried over that round, so we just add here. 4, 4, 6, 9 and 6, 15. Carry the 1, and we have, do we have 5,544, or do we have something else? So now you have to look at basically what you started with. Try to tie the connected estimated product to your real product and look and see, where should I put the decimal? So if you start thinking, okay, I should be around 50, then you would just plop it right here without even thinking about where it is up here. If you want to start thinking about what you should be thinking about, it's that there are 2 places to the right up here, or this is 231 hundredths. Therefore, if it's hundredths times ones, you would get hundredths in your answer. So that's what I think about when I am placing my decimal. And of course, you want to tie back with your estimated product and make sure you're in the ballpark. So here we have 5 and 42 hundredths times 305, but we're just going to have an estimated number here, and I want to keep it really simple. So I'm just going to work with like 5 and say 300. This one easily falls back here. But as we get into some higher or different decimals, they're going to put in something where we might have to use a 5 here. But anyway, we don't have to use it here. So just have your 5 times 3 for 15 and your 2 extra zeros, so we know we're looking for an answer around 1500. Standard algorithm. 5 times 2, 10, carry the 1. 5 times 4 is 20, plus 1 is 21, carry the 2. 5 times 5 is 25, plus 2 is 27. So that's your first partial product. Now, look at the 0. So I'm done with the 5 ones. Second row, I would work here, but there's a 0. So I'm going to hold that spot with the 0 and move on over to the hundreds place and start multiplying with the 3. 3 times 2, 6. 3 times 4, 12, carry the 1. 3 times 5, 15, plus 1, 16. And now we can add down in our columns, and we've got 0 and 1, and 7 and 6 is 13. Carry the 1, 2, 2, 4, plus 1 is 5, and 6 and 1. Thinking again, is this my answer? No, I'm going to have to put in a decimal, so where do I put it? I've got 4 digits in my real answer. I should have 4 whole numbers in my real answer here, and think 2 places here, 2 places here. This is my final answer, 1,653, and 1/10 or 10 hundredths, those are the same or equivalent. Top of the next. Same Same directions, only this time they're taking away the space for the area model that we didn't do so that they can give you lots more practice. Hooray. So estimating, and again, estimates may vary. You have to do what's comfortable for you, but I'm going to try to make things as easy as possible. You can do 1 times 21. You can do 1 times 20. Doesn't really matter because either way you're going to get something that's 1 digit apart. And so now we're going to use our standard algorithm. Be careful when lining up your digits. And I hope your place value columns are all nice and neat. 1 times everything, I expect it to be 123. And look, 1 times 3, 1 times 2, 1 times 1. There it is. Done with this, hold that spot, move on over to the tens place. 2 times 3, 2 times 2, 2 times 1. Add up your partial products. We have 3, 6 and 2 is 8, 4 and 1 is 5, and 2. But since my final answer is going to be around 20 or 21, I'm going to plop my decimal there for 25.83, 25 and 83 hundredths. And you don't have to write your other answer, just circle it. Next one, just do something simple. 3 times 40 is fine. Then you've got your 12 with the 0, so something around 120. Again, keep it simple. You can have either one on top, the 3 and 2/10, or the 41. Just remember that you're not multiplying this, you're actually multiplying these numbers. So I'll just write that since the 3 and 2/10 is first. Line everything up carefully. Again, multiplying with 1, it should be pretty straightforward. Then hold this spot with a 0. Move over to the tens. 4 times 2 is 8. 4 times 3 is 12. Add them up. 8, 9, 10, 11. 3, 1. But is it 1,312? No. We're looking for something around 120, so 131 is actually a lot closer. And so we're just checking to make sure everything is close. Now look at, here's this, I don't know if this is the first time we've had this, but we don't even have 1. So what do? Are you going to change it 41 times 0? Oh, well, my answer would be about 0. No, we're not going to do that. We're just going to use about 3/10. So that would be your 1 factor. And then the other one, let's just make it 40 so that we're keeping it really simple. Drop the 1 off so we don't want any hassles. Now, if I have 3/10, remember the unit form. That's really helpful. Times 41s. Okay, because the 3 times 4, that's your 12, but you have that 0. So tenths times 1s are what? Tenths. So my expected answer is going to be somewhere around 12. Now I can set it up with my whole decimal. And I do always, if I have more digits on top, even if it's a 0, I put that one, I put that factor on top. Okay, and still got that nice one, super easy. And then you can put the 0 here. It's kind of irrelevant, but you can definitely put that to hold that space if it makes you happy. Done with the 1, so put the 0, move to the tens place. 4 times 2 is 8, 4 times 3 is 12. 2 goes down, the 1 goes up, and then you multiply it and get a 0, and then the 1 comes down. And then we're going to add these. 2, 8, 9, 10, 11. 2 and 1 is 3. And we end up with, now what? Where's my decimal? Someplace right around 12. So 13 and 12 hundredths. Comparing again. Okay? Next one. If I have, make this, if I have less than 1, make it really easy to work with. So I just have this 5/10. And anything close to 62 with a 0, you could, I would use 60. And again, the 6 times 5, you're going to have your 30, and it would be 30, and then you would have your 0, and then we would have tenths, and so we would pull it back, and we would have our 300 tenths, and you can write out your unit form if you'd like to, but I'm going to use this space and do my standard algorithm. So 2 times 4 is 8, 2 times 5 is 10, the 0 goes down, the 1 goes up, 2 times 0 is 0 plus the 1, and it falls down. Hold this spot with a 0, move to the 6. 6 times 4 is 24, carry the 2. 6 times 5, 30 plus 2, 32. 3 goes up, and it's 0, and it falls down. Those zeros just don't hold anything. 8, and then 4, and 3, and 3. And so thinking about if I have hundredths here, I should have hundredths here, double checking. Your 33 and 48 hundredths, pretty close to 30, or you don't have to say 300 tenths because we've got the right place value position with our decimal. Okay? Moving along. Now here we have 6, so we're just going to use the 6, and we've got something close to 30. So 6 times 3, got your 18. Don't forget the 0. And these are all 1s, so that's 1s. 6.09 times 28. 9 times 8, or 8 times 9, 72. 2 goes down, 7 goes up, and falls down. And then we're over here, 6 times 8, 48. Second partial product, fold that with a 0 because we're moving over to the 2. 2 times 9, 18. 8 down, 1 up, and then that falls down. And then 6 times 2, 12. Line up carefully. And check all your digits so they're always lined up under the digit that's in the same place value position above it. 2 comes down, 8 and 7, 15. Carry the 1, 8, 9, 10. Don't forget to add the carried numbers, 4, 5, 6, 7, like I do sometimes. And then we have hundredths here, so we have hundredths here, checking to make sure 170 is close to 180, and it is. Next one, I'm going to take this 6.83 and I'm going to bump it up to 7 because that's a little bit closer. When it's 68, it's just closer to 70. And then 683, again, here I have all 1s. Why not just bump it up to 700? Use the 7 times 7 for 49. Hopefully you know your math facts. Don't forget your extra zeros. It clearly doesn't matter which one's on top. They're the same digits. Just one of them should have the decimal, and it doesn't matter if it's on the top or the bottom. We're going to have 3 partial products instead of 2. So make lots of room or write small. 3 times 3 is 9. Then we have 24. Carry the 2. 18, 19, 20. Next row, working with 8. 8 times 3 is 24, 64, 65, 66, and then 48 and 6, 54. Third row, here's where kids are maybe starting to get the hang of it. Okay, we're done with the 1s. We're also done with the 10s. You should be in the hundreds place starting your multiplication. 6 times 3 is 18, carry the 1. Then we have 48 plus 1 is 49. I got a 4 up here. Then I have 36 and 4 for 40. It's like, what is that? Is that just a mark in my book? Nope, it's just random pencil. Okay, so then add your partial products. 9, 8, 14. Let's use the 10 here. And then 6, 16, 6, 4. Double check. We need to be around 4,900, so 4664. I can put my decimal here. Double check hundredths here, hundredths here. Circle your answer and you're good to go. Okay, move the page. All right, let's keep going. Another 6, got to work on your 6 times tables and really close to 200. So using 1200, and then we've got lots of nice zeros. 6.09, 208, and start multiplying. 8 times 9, 72. 2, 7 up, 7 down. And then move over 48. 48, 72, first partial product. Second row, we're done with the 8s, done with the zeros. Move over here to the 2. 2 times 9, 18, carry the 1, and the 1 comes down. 2 times 6, 12. Make sure all your place value positions are in the right spots. Check your digits that they're lined up correctly. Add carefully. 16, 4, 5, 6, 2, 1. Where's my decimal go? 2 places here, 2 places here. 1,266, 1,200. If you're nice and close. Great. Final answer. There we go. Okay, big numbers here. So what should we do? I want my rounding to be easy. Make it easy. 171, pretty close to 200. 555, you'll see kids go both ways. Let's just stick with our typical rounding fashion, go up to 600. Could you use 55? Sure you could. 2 times 6 is 12, and then I have 4 zeros. So this one's going to be a doozy with 120,000 as your approximate answer. 171.76. Line up carefully. 5, 5, 5. Now the cool thing about this one is that our second factor is all 5s. So once you get your first row, then it's just about the placement of the zeros. 5 times 6 is 30, so be careful and do it right the first time. 5 times 7, 35, 36, 37, 38. 5 times 1, 5, 6, 7, 8. 5 times 7, 35. And then 5, 6, 7, 8. So you should have 8, 5, 8, 8, 0 as your first partial product. Now, watch. Done. Row 2 is going to be the same numbers, but bumped over 1. Okay, so I'll do it all again so you can watch. 5 times 6, oh, it's 30. 0 comes down, 3 goes up. Then we have 35, oh, 38, 3 goes up. 5, 8, oh, 35, oh, there's the 3, 5, 6, 7, 8. Now look at what I mean. 8, 5, 8, 8, 0. Now after I held this place, 8, 5, 8, 8, 0. Ha ha ha. So what do you think the third row product is? Well, hold the ones place, hold the tens place, and then multiply with 5 again. Oh, the lights go up just to keep things exciting. And so I think it should be 8, 5, 8, 8, 0. 8, 5, 8, 8, 0. 8, 5, 8, 8, 0. I'm going to take my chances and believe that 5 times 171.76 is going to give me the same answer, and it will. So add your partial products. 8 and 8, 16, then 16 and 17, 8, 22. Carry the 2. 10, 18, 23. 10, 15. And 9. And so we should be somewhere around, here we are at hundredths, 95,000, and somewhere near 120,000. But remember, we went way up here and way up here. So this is a gross, this is what I call a gross over estimate. Okay, so yeah, that's pretty far above what my estimated product should be. But 95,326 and 80 hundredths or 8 tenths is actually correct. So if you wanted to have a more precise estimate, then you could kind of fiddle around with those numbers. But we're going to move on to the back because there are a few more problems. And do click subscribe. I hope you guys are helped by these videos. So let's start with Eric's goal is to walk 2 75 hundredths miles to and from the park every day for an entire year. That's lofty. If he meets his goal, how many miles will Eric walk? So I think I've had a lot of kids ask, what do they mean? Is 2 75 hundredths the distance to and from? Actually, the book wants you to believe that this is the one-way. And so we need to get him to go to and from so he doesn't have to sleep at the park because that would be sad. So we've got to double that. So if you were to set this up in like PEMDAS fashion, then I would have to multiply this by 2. And then I would also have to know how many days are in a year, which a lot of 5th graders don't know. So that is 365. Now, if you're just learning that on the video, then you would want to take some time to work this out and then multiply by the 365. So pause, do it. Okay, now if you're coming back and you've already done this, so let's take a look at best way to solve this. The 2 75 hundredths times 2, you can just set that up over here, or you can add it twice. Nobody's going to, it's not a penalty. 5 times 2 is 10, 14, 15, and then 4, 5. So it's 5 and a half, 5.5, 5 and 50 hundredths miles each day, times the 365. So since I have a 0, I'm just going to move this over here and set up my multiplication this way because I like it when I have a 0 on the bottom. So now I can hold that place, dun, 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 move over. 25, then 32, 15, 16, 17, 18, and then I'm done with both of those. So I can move over here and I only need 2 rows of partial products. And again, it's another 5, so I should expect it to be 18250. So 5 times 5 is 25, carry the 2, 32, there it is, 15, 16, 18, 18250 from the first row, but you have to have that extra 0 there. So don't take any shortcuts until you're comfortable with your zeros. And then 5 comes down, and we have 7 and 10, and carry that 8, 9, 10, and 2. And so this was hundredths times ones for hundredths. And your final answer would be miles in a year. 2007.5 or a half, you could say. 50 hundredths, 5 tenths, it's all the same. Okay, next one. Art galleries often price paintings by the square inch. Wow, I honestly did not know that, so interesting. If a painting measures 22 and 5 tenths inches by 34 inches and costs $4.15 per square inch, what is the selling price for the painting? So again, if you're going to find the area, which is square inches, then we have to multiply the 22.5 by the 34 first, and then we can multiply by the $4.15. So the kids can do this in any order. Remember, commutative property, you can kind of move things around, but let's get the area of the painting so that we will know what we're working with, because sometimes it will help if you have the right size painting. 5 times 4 is 20, 8, 9, 10, 8, 9. And then hold that. 3 times 5, 15, carry the 1. 6 and 1 is 7. 3 times 2 is 6. 0, 5, 16, 76. And that's only tenths. Tenths times 1 is tenths. So we should end up with our 765 inches squared times the 415. Let's set it up over here. This is cost. Yes, you wouldn't want to mix that in with the size of your painting. That would be not good. And then we're going to have 3 partial products, so make lots of room. 5 times 5, 25. Then we have 30 and 2. And 35, 38. Next row. Hold that. A 1, how lovely. 5 and 6 and 7. Next row. 0, 0. 4 times 5 is 20. Another 0, carry the 2. 4 times 6 is 24. 25, 26, carry the 2. 28 plus 2 is 30. That's okay that it's sticking way out. Add up here. Add here for 7. Then we have 14, 7, 10, 16, 17. Carry the 1, and then 3. Now what is that? That is hundredths times ones for hundredths. Put your comma in. We're trying to find the selling price for the painting, and it would be $3,174.75 is the selling price. There you go. Okay, last one. Finally. Gosh, this is a really long day, long video, sorry. Gerry spends $1.25 each day on lunch at school. On Fridays, she buys an extra snack just on Fridays for 55 cents. How much money will she spend in 2 weeks? Now, you can always do these with a tape diagram so that you will get the right number of days, because if she's at school, that's going to be the 5 days, but the Fridays is only going to be the 1. So there are many different ways you can set this up. You can have your tape diagram with your Monday, Tuesday, Wednesday, Thursday, Friday, and then each day is going to be the 125. like that. You can do your multiplication times 5, but then what do you do with your snack? Well, you're only going to have 2 of those because this has to happen for 2 weeks. Okay, so this one is actually going to be more than the 125, or you can do your 55 extra twice. So there are a lot of different ways students will set it up, and it's all good, but I'm going to do the 125. And if you do times 5 to get the cost of, say, 1 week, and then you want to tack on that 55 cents, that's fine too. You can do it times 10 and then add in the 2. That's fine too. So many different ways. So since I already wrote it this way, let's just finish it. 5 times 5 is 25, 10, 12, carry. 5 and 1 is 5, plus 1 is 6. So that's 625 is only for the lunches for 5 days. But 55 cents would be the total cost for 1 week. And so we're just adding that. We're not multiplying it because it's only a one-time fee. So there's 5 and 5 is 10. Carry that. 7, 8. And so 680 per week times 2. 0, 16, 12, 13. And then you can end up with your $13.60 spent in 2 weeks. And that works, but you don't have to do it this way, but you should end up with $13.60 as your final answer when you get all your snacks and food calculated. Anyway, that's the end. Finally, thanks for hanging in there, and we will see you on the next video. Bye for now.